Hello everyone, I'm Aryan and in this video we'll discuss about QUIC and the concepts related to QUIC. We'll start from what is QUIC, why do we need QUIC, the functionalities and formats of QUIC. For that we'll look into Wireshark. Apart from that, we'll check the security threats and the scalability of QUIC. We'll also discuss the examples where QUIC is currently used, all the network applications. Let's start. Now what is QUIC? QUIC stands for Quick UDP Internet Connections. It is a relatively new protocol and it operates on transport layer. It is designed for better and efficient web performances. It is similar to TCP but it uses UDP instead. Now using UDP gives it some advantages in terms of efficiency and speed, but we'll discuss more on that later. Now why do we need it? There are some key factors to that. Let's discuss that. Starting with the first point would be speed and efficiency. Now, traditional TCP is reliable, I agree, but it is slower in terms of connection establishment, in terms of data transfer and data lost retransmission, packet loss retransmission. Now, QIC beats TCP in all of these with the help of using UDP. As QIC develops the connection much faster, the data transfer speed is much faster, and also these things are beneficial and efficient in cases of like real-time simulation, uploading an image where the packets are much more important for some cases, and also real-time gaming. Another point I'll consider is avoid head of line blocking. Now consider the data transfer as a highway. Now if there's only one data stream, only one highway, and there's a traffic jam or there's some accident, then all the packets will be stalled. Similarly, if there's a packet loss and there's that packet loss is gone for retransmission, then all the previous or upcoming packets would be stalled and will be waiting for that retransmission. But in case of QUIC, there are multiple highways and multiple data streams. Now in that multiple data streams, what happens is that even if the one data stream is blocked, there are other ways, and not all data packets are being stalled or paused. At the end, there's one more point I would like to add, that is avoiding handling of network errors. Now QIC has its built-in technique known as FEC, that stands for forward error correction. What FEC does is that it creates its own data packet whenever there's a data packet loss instead of retransmission. Now this is a very good technique and it avoids packet loss retransmission, that ultimately saves time and ultimately makes QIC much more faster. Now let's discuss the functionalities and frame formats of QUIC. Starting with reduced connection establishment time. Now, connection establishment time is a three-way process, but QUIC eliminates those three-way process and establish connection much more faster, which is efficient and beneficial. Moving on, we have improved congestion control. QUIC monitors the network condition and the data transfer very precisely and very efficiently, due to which it allows the data transmission in order accordingly, so that there is no congestion, and basically prevents the data when there's a condition for congestion to be approached. Moving on, we have already discussed about FEC and multi data streams, that are very important functionalities of QUIC, with the reconstruction of the data packet loss and multiple data streams. I'll add another point in the functionality, which is the security. Now QIC uses the TLS encryption method that makes sure that there's a secure connection between the devices during the transmission of the data. Now for the frame formats, I'll walk you through my Wireshark and we'll meet there.
So this is my Wireshark. Now let's discuss the frame headers and the frame types of the QUIC. Okay, so there are many types of frame headers, like the version negotiation packet header, format packet, initial packet, zero RTT packet, and handshake packet, and many others. I will here be discussing the initial packet. So initial packet is the first packet which is exchanged when the establishing of the connection. It is a long header packet which contains the following things. The first one is the packet length. Okay, so the packet length tells us the total length of the packet. Uh, then we have the header form. It is the long header form that is used for sending the initial establishment. Then the fixed bit, it has to be set to true for long header formats. Then we have initial, it is zero. Basically the code for initial is zero, depicting that it is an initial kind of packet. then we have reserved bit. It is set to be 0. It has to be set to be 0. It basically means the future bits that are reserved. Then we have the version. Now the version indicates the version of the QUIC that is being used by this packet. Afterwards, we have a destination connection ID. This tells us the destination. This identifies the connection of the recipient. After this, we have the packet length. Now this is the packet length. This packet length indicates the length of the packet number, and it means that how many bytes are used to encode the packet number field. Okay. Now let's discuss the QUIC frame types. Now the first one here is ping. Okay, so this is ping, and its purpose is that it is used to measure the RTT, the round trip time, and keep connection alive by triggering response from the peers. Then we have the padding here. Now this padding length is 41. I'll tell you what it means. It is used for padding, as the name suggests, so that the minimum packet size is acquired. This 41 means the amount of padding that is done on it. Then now, for example, 6, so the padding would be 6. Then the next is the crypto frame. This frame carries the cryptographic handshake message during the establishment. Now, if we go down the crypto, here we have the handshake protocol, the TLS v1.3 handshake protocol, which is the client hello. Now, when it is the client hello, it basically is initiating the handshake process with the client. So this is what it means. Now, if we go on to the next packet, which is the 0 RTT packet, you'll see that the decryption failed here. Now, failed to create decryption context because the website I accessed maybe does not have any previous cached data, uh, and there are no secret keys available for it. Now, let's go back to the video.
There are some pros and cons affiliated with everything. Similarly, there are advantages and disadvantages of QUIC too. Let's start on a positive note with the advantages of QUIC. So to begin with, the first advantage I'll count is that QUIC has a much more faster connection establishment. The second I'll consider is the handling of congestion control. Of course, it handles the congestion control much more effectively and efficiently as compared to other protocols such as TCP. Also, the multiplexing in QUIC basically is a faster data transfer, and it is effective in cases especially for real-time simulations, real-time gaming, and also the data transfer in high latency jobs. Of course, the most significant advantage of QUIC is that it develops the connection faster. Now, I'll deep dive in this point and basically elaborate on this. Now, as TCP is a connection-oriented protocol, it has to perform that handshake, that three-way handshake. But QUIC here takes a lead with its 0 RTT feature. The 0 RTT feature is an interesting feature, and it stands for zero round trip time. Now, what it does it basically sends some data to the server prior to the confirmation for the establishment of connection. Now, the connection is not established, but the data is sent. That's interesting. Let's break down how it is done. So this feature basically hinges on the client, which has some prior connection with the server. So what it does is that it hinges on them, and the server has some secret keys for the further connection, and the server shares the secret keys with the cache of the client. Now, whenever the client wants to establish a connection, this cache basically encrypts the application data for the further use, and it basically encrypts the application data and sends the application data to the server in a UDP in a QUIC packet, not UDP, QUIC packet. Then this QUIC packet goes to the server, where the server decrypts this packet. Now, there are only two possibilities: either the packet would be a valid decryption or an invalid decryption. Now, if the valid decryption is there, that means that the keys that the server got are valid. Then the connection is established. You are good to go. You can now share and receive data. But if there is a invalid decryption, the keys does not match and are said invalid, so then what happens is that the server basically sends a message to the client that the decryption failed and now you need to do a general handshake procedure, and this won't work. So that's how zero RTT method work. Now let's focus on the disadvantages of QUIC. Now, firstly, as the QUIC is a relatively new protocol as compared to other protocols like TCP and HTTP, which are well established in market, replacing them with QUIC would require a lot of money and a lot of time, along with efforts and expertise. And doing that for all the globe and all the servers would be a hectic job. Additionally, as QUIC is complex due to its complexity, and it's not everyone's cup of tea, it requires a lot of expertise. And QUIC features and encryption layers add layer and layers of complexity to it. Additionally, as QUIC works on UDP, it might cause a resistance for it to do on all the platforms, because some network administrator may think that it's work on UDP and have security concerns related to it. Apart from all of this, we know that QUIC is the future and is a promising protocol for the future. Now let's discuss the security threats, because that's an important topic that needs to be discussed. QUIC has its own TLS encryption. There are certain security threats that needs to be considered. First one would be limited visibility. Now, the traditional network security tools analyze these packets and inspect them for any kind of threats. But in QUIC, the data is basically encrypted with the UDP packet itself, and then it is sent. Due to which these tools are unable to differentiate between the malicious data and the actual data. So this creates a blind spot for them. Another would be novel attackers. Now, what we get to know is that it works. What we know is that QUIC works on UDP, due to which it has some new grounds of attacking, like the multiplexing and all the other complexities, which are not explored until yet and are unexplored. So these attackers can basically explore them and use them, basically misuse them for launching different attacks like denial of service attack. Next would be deployment issues. Now, the relative novelty of the QUIC introduced deployment issues, and the misconfiguration of this QUIC on the server and the client side may cause security threats. Although QUIC has been created by keeping security in mind, they are working constantly on to improve the security threats, and they are putting in so much research and development behind this. Now let's go on our last topic of the day, which is scalability. QUIC has a lot more potential for scalability as compared to any other protocol. I'm saying this on count of few factors. The first one is reduced load server. Now, eliminating the three-way handshake process, the QUIC has reduced the server overload, and due to this, it translates to a better performance to all the users that are accessing the server simultaneously. Also, due to the eliminating the congestion control in QUIC basically gives a more smoother and faster flow for the network transmission. Next one would be stream multiplexing. Now, as we know that the QUIC has multiple streams of data transfer, and due to this consolidation of multiple streams, QUIC basically saves on the server resources and provides a more efficient network consumption. The last point would be reduced head of line blocking. As we know now through this video what is head of line blocking. QUIC deals with the head of line blocking with its multiple segments. This gives a much faster and much smooth approach overall. Now at the end, I like to conclude by saying that QUIC is being used and being experimented in the industry with the help of multiple mega giants. Like Google is using QUIC, various streaming platforms such as Netflix is also experimenting with QUIC, and QUIC is being adapted and used in various mobile applications that need real-time configuration and very low latency like video calls or meets, etc. That's up for this video. If you like this video, do like, share and subscribe to my channel. Thank you for this. Thank you for being there till here now, and see ya.